available experts, please report to room A9.
Hello guys, Active here, and welcome to Color-Symbolic Interpretation module. This is what the module will look like. We'll have an operator sort of thing here. We'll have an input, which is this screen down here. An output, which is what we've got to type in. The keypad here, and the stage counter here. The stage counter here will just go up, and we have 4 stages. A red number implies negative, so this is negative 37, for example. You might wonder why I have put these 2 notes here already, I and O, because we need to keep track of our inputs and outputs, because it might refer to previous outputs, the first output, the first input, and stuff like that. So our first input will be negative 37, and we'll get the output after we've figured out what our function is. There are 2 different types of color functions, dependent and independent. Dependent ones refer to things from previous stages. Independent ones just rely on whatever factor you have as the letter here. With the best case scenario being grey, where you just submit the number you were given. Do note, be warned about multicoloured. Do not fool it for the first colour it is. Keep an eye on it, and if it starts changing colours, that's what multicoloured means. But in this case, we have I think blue here. Blue and minus. So the wording here is slightly confusing. When it says here, subtract to the previous output, that means subtract the previous output from it, basically. So our number is negative 37. Our previous output, we don't have a previous output, which is what this for reference is going to say. If this value has been used on the first stage of the module, apply factor Z for its value, which is concatenating the 3rd and 6th serial number character, which is 11. So, using 11, subtract the previous output 11 from it, and then subtract it by the factor. The factor will be the letter up here. That is letter A. The amount of consecutive successive submissions, we currently have none, so we're going to be subtracting 0. So, completing this, we get negative 48, so we're going to type in 48 negative, and hopefully if we've done this right, we move on to the next stage. You'll know if you've got it wrong if you get X's across the bottom, the right hand side. So our next input is a regular 50, and this colour is white, which is one of the independent colours. Replicate the colour from the previous stage. Previous stage we have blue, so in this case we're going to refer to this as if it was blue with the symbol is attached to. So effectively we have the same rule again. We have a blue minus. I might not explain that at the start. The table we're using here is the colour and the symbol that's on the front. The independent colours only need the colour. So, using our input, so we're going to be subtracting the previous output. This time we do have a previous output. So 50, subtracting from it, subtract the previous output from it. So the previous output was negative 48. This is going to be 50 minus 48. And then subtracting the factor, which in this case is S this time. Which is total sum of the zero number digits. 7 plus 1 plus 1 is 9. 7, 8 and 9, yeah. So we're going to be subtracting 9 from it. So, figuring that out, we get positive 89. And if we've done this right, just check out, mess anything up. I think this is good. Yeah, we've got the right input there. No doubt that was our previous output. Stage 3. Effectively, you're going to be repeating this 4 times, basically. Be careful with this. This is a multiplication symbol rather than a... It is a multiplication symbol rather than a addition symbol. An addition symbol will look more like a plus. It is multiplication, but the colour is white. Replicate the colour from the previous stage. But the previous stage we also had white. So the reference here, 5. If the first or previous colour of the stage was white, then no action is required. So we're going to take our input and have it as our output. The previous stage does not count as being blue because the actual colour of the previous stage was white. So since it stays white, we just do nothing. So negative 55. And we still have that stage as well. Our final input, we don't really need to note it down because it's the last stage. We have a blue. We have blue and minus. So we've got the same rule again. So take our input, negative 69. Subtract these previous output from it. So minus 55. 69 minus 55. And then minus the variable or the factor n, which the last digit is a 0 number, which is 1. Figure this out. We get negative 15. If you mistype like this, just type what you actually want. So, hopefully, doing all of this right, we get self-module. Of course, doing this, I was never going to get through every single one of these. The dependent colour functions are effectively all the same. Just this column will prioritise adding, this one prioritises subtracting, and this one prioritises multiplication. But the independent colours are interesting. The dark red, if you get dark red, you only have to add the factor, not anything else from previous stages. Same with green and blue being subtract and multiply. Multicoloured, you just completely ignore the input and just have the factor as the answer. White we saw, and then grey, like I mentioned, was the best case scenario. You don't do anything. This is a classic just do what it says sort of thing. And it can ask for previous outputs and inputs here as well. Just go over the notes here. There is, if it's red, it's negative. If the number you get does not fall within minus 99 and 99, we didn't actually ever get that, but it can happen, especially with the multiplication. You effectively modulo it by 100, but keeping negative signs, so similar to like how it works in like Simon's stores. You sort of just add or subtract 100 to close in on something until you have two numerical digits, maybe with a minus sign on the front. The non-white displays on the right side module have the corresponding colours marked with this number. If we look up here, that's referring to red, green and blue. So if you don't know what dark red, dark green and dark blue are, if they look red, green or blue but don't match the things that look down the side, then that's what it is. It's dark instead. We mentioned the first stage stuff. We mentioned the white thing. This one's an interesting one. If the absolute value of the input number is 0 or 1, so if you get 0, 0, 0, 1 or 0, 1 in red, then you just ignore the factor and just apply the formula without, as if it's not there. In the off chance to get multicoloured, which was replacing with the factor, you just put 0. This is just like an interesting case. Oh yes, because this is specifically attached to this one, because if you get L here, 1 and 0 don't have a largest prime denominator. 1 because he doesn't have any, and 0 because he has all of them. So in that case, you can just ignore it. Finally, the stage is considered generated when the input display shows the input number. That's for the strike rules, if you have an X here. Other than that, I don't think there's really anything else I have to explain. The other buttons were self-explanatory. Minus negates the number, enter enters your input. So, hopefully, Color-Symbolic interpretation module makes a bit more sense now, and I'll see you guys in the next tutorial. I'll see you later.